Okay. Where's my slide? Okay. Okay. So ni belum ni before we go to stability, I think we should recap first or refresh our learning before on buoyancy by doing this example. Okay. So a cube of 80 millimeter on a side is made of a rigid foam material and floats in water. Okay, water with 60 millimeter of the cube below the surface. Calculate the magnitude. Say again, they ask you to find the magnitude and direction of the force required to hold it completely submerged in glycerine, which has specific gravity of 1.26. Alright, siapa nak ni buat macam biasa? Who want to help me to do it? Ada? Anyone? Siapa nak buat? Tak ada. Ni recap je ni on buoyancy. How you find the FB and W, the FBD, draw the FBD. Come on. Siapa? Hello? Kita putus ke?
Saya try lah.
Oh, okey ada. Sekejap, biar saya teka. Awak ni kan siapa? Aiman bukan
Ya betul.
Aiman lah. Okey. Okey Aiman.
Nak try lah. Tak tahu betul salah.
Tak ada hal.
Okay, first dia dah bagi volume cube.
Okay.
Yang full dengan bawah masa dia masuk dalam air.
Okay, let me draw so that people can see. So this is the cube. Sorry, not really. So this is the level of water. Okay. So ni water put water. Okay, dalam okay Iman, this apa ni 60 meter 60 millimeter. So this is 20 millimeter. Okay Iman. Next.
Next dia punya weight ke bawah.
Weight ke bawah. Alright.
Satu FB ke atas.
FB atas. Okay.
Dengan FE. FE dia
no, this for floating. We don't have the FE kan.
Oh.
Untuk floating macam ni, so we don't have the FE. If submerged, then we have this another component. Remember? So this is float in water.
Oh, so dia tak perlukan apa ni daya untuk tenggelamkan dia.
Yang ni tak payah. So you just summation of
yes. Fy
betul?
Equal to 0.
So 0. Okay.
So FB minus FW equal to 0.
FB minus W 0, yes. So FB
equal to W.
Okay. So how you find the FB?
FB equal to rho GV.
Rho GV. So rho of what?
Rho of cube. Rho of water.
This is buoyancy water. Okay. V
cube sama.
V cube or V or the displacement V here inside this. I mean that
V inside the water.
Yes. So we call it V displacement Okay, because it displays the fluid end. Okay, so the value is the raw of water is
1000.
1000 times
Specific gravity guna 1.26 tu tak apa? Yang 1.26 tu?
Ni untuk jawab soalan lain. Ni
okay.
bermula first they said the cube is floating in the water. Kau you want to find the B, the FB kan, or W first. Then
Okay.
they ask you to calculate when the cube is submerged in a glycerin.
Oh, tu
So
untuk
we have-
glycerin punya.
Yes, we have another FBD lagi lah nanti.
Okay.
So this one you just do it to find the W, so that you can use it when you want to solve the question, the next question.
Okay,
Can?
so 9.81
Okay. Times.
and times
What is the volume displacement? Here.
6
Yang ni je, yang tenggelam, yang submerged dalam air.
60 millimeter.
60 millimeter. Okay. I think we should convert in meter, right?
0.06 meter.
0.06 meter. Okay. What's the volume? There's only one. Times.
Sebab dia cube sama-sama lah. 0.06.
Okay, remember the cube is like this kan? Okay, 0.8, 0.8, 0.8. Betul?
Yeah.
But now the displacement volume kan dia hanya separuh, dia hanya yang tenggelam lah. Kan?
So yang lain 0.8 lah.
Yes. Not 0.08 I think millimeter.
0.08.
Yes, 0.08 times 0.08. Let me allow some people in this. Sekejap ada orang nak enter. Okay, that's why when you are late you disturbing all the people. Okay, again, sekejap okay, Aiman, continue. After that, so what's the value?
The volume
No, all this 1000 times 9.81 times the volume.
3.77
77. What's the unit?
Newton.
Newton. Okay, good. So you find now you find your FB or W lah sama. Okay, now you have this. So you can answer this question lah. You said when calculate the magnitude and direction of the force required to hold it submerged. Okay, now the cube is submerged in a glycerin. Okay, ni raw glycerin, dalam glycerin. So ni level of water, level of the glycerin. So you still have your FBD W ke bawah. Okay, and your FB. What else you need in the FBD?
FE.
FE kan. So you want to assume upward or downward first? The direction.
The downward first.
Okay. Doesn't matter what direction you assume. You just do it so that when you calculate and check the number whether it's true or not. Okay, now what's the equation?
Summation of Fy equal to 0.
Okay. Alright. Then
Then negative Fe
negative Fe
minus W
W
plus Fb
plus Fb equal to 0.
equal to 0.
Alright. Now you want your Fe equal to
Fe equal to W minus Fb.
Are you sure?
Yes.
Huh? You put this Fe to the side.
So negative W plus Fb.
Yeah, so FB minus W lah Okay, make sure this is very easy to do mistake arrange it, the equation carefully. Alright, so now you want to find your FB lah. Okay, alright, to find your FE kan. So FB here, apa Aiman dia punya formula?
Rho glycerin,
Glycerin,
G glycerin.
G constant man, gravitational.
Okay.
G 9.81 is similar lah for any, the rho is different, rho glycerin. Okay, and then V kan?
Volume.
Okay, alright. So you have your rho of glycerin, how much?
Glycerin 1.26.
This is specific gravity.
Specific gravity.
How you find this the rho? Is just by
multiply 1000.
yes, you multiply by the rho of water kan. Remember the specific gravity formula dia kan, rho apa darab dengan rho of water tu dapatlah specific gravity kan. Okay, so don't forget this formula. So they will give us 1260, okay, times G. Now times V. What's the V now?
0.08
Okay,
times 0. Power of 3.
cube but now the volume is all this volume. Okay, now because the cube now is fully submerged, so the volume of the block lah. Okay, 0.083 cube. So what's the value for FB?
Newton.
6.33 Newton. Okay, now you can find your FB lah, because you already have your FB, and W you already find your W here. Okay, so now FE equal to FB minus W, so your FB is 6.33 minus 3.77. What's the value?
2.65
Newton.
Okay.
And the direction you assume is betul lah very positive. So this is the magnitude and the direction is downward lah. So that we need to put a force to hold this cube remain submerged in the glycerin. Okay. So that's how you calculate this ni lah, how you answer this question. Senang je kan?
Sir. Nilai yang tu 2.56. Salah terbalik.
Oh ni salah. Okay. 2.56. Oh sorry. Alamak, saya terpadam pula. Sorry, saya baru guna pen baru ni. Apa dah rekod apa? Nanti ada dalam tu kan. So 2.56 Newton
Betul.
So that means we need to put a force on this cube so that it's completely submerged in the glycerin. That means this row and the row of the cube, apa maksud dia? Row of the cube ni apa? Lagi rendah ke lagi tinggi daripada row of glycerin?
Lagi tinggi.
Lagi tinggi.
Okay. So we need to put a force to make it submerged. What is mean? Apa maksud apa?
Sama kot. Sama kot.
So maksudnya kalau tak ada force ni, benda ni akan terapung kan? Betul tak? Kalau awak tak kenakan force ke bawah, benda ni akan terapung. Betul?
Yes, betul.
So apa maksud row apa? Adakah row of this object lagi tinggi atau lagi rendah daripada row of the glycerin?
Lagi rendah.
Lagi rendah.
Rendah kan? So any object, whenever the density is lower than the fluid, so it will float lah. So that's why you need to put the force downward. If the object if you calculate the FE and you find that your FE is in this direction, that means this object, the density of the object is higher than the fluid, and it will sink So that's why you need the force in upward direction to make it submerged in this fluid. Kan? Betul? Faham
Faham sir.
Alright. So that's the ni lah kita refresh sikit on buoyancy, because stability, when we go to stability, it is related lah to buoyancy. We still need the FB, the W. Okay, so that's why I want to recap first, so that we not really forgot all the things that we have learned before. Okay, now we go to the floating. Okay, buoyancy, like I said to you, is very simple, very easy. I'm sure you can do it. If you do all the tutorial, I think you will get it. So now stability. Okay, what is stability? It's the ability of a body, whether the body is submerged. In this case, it's submerged. So this is the fluid. So the body is submerged or floating. So like this ship is floating on the fluid, to return to its original position after being rotated a small amount of above a horizontal axis. Macam kita apa, I think semua ni kan pernah naik kapal, or maybe boat ke apa, the boat, whenever there are any wind or any wave pushing the boat about this horizontal axis, the ship will rotate it a little bit on the right, and then after that it will go back to the original position. So that's the stability lah. So the object remains stable whether it's floating or in this submerged fluid. Okay, that's the theory lah. Okay, so we have two different scenarios lah. One submerged, okay, this one submerged, and another one is floating. Okay, so we go submerged first, because submerged is very easy, not too complex. Floating a little bit complex, not complex lah, little bit ada lebih sikit lah apa dia punya komponen. So submerged sangat senang. How we can know the fluid, I mean the object is stable in the submerged fluid. Okay, and immersed naturally buoyant body is stable. Okay, this one, tengok ini if the center of gravity G, okay, CG, let we call it CG, because we using CG after this. The CG is directly below the center of buoyancy, buoyancy CB, okay, of the body. Because you know in buoyancy you find the force of buoyancy, but we never locate where is the center of that buoyancy force. So in this stability we have to know where is the center of buoyancy. So for any object, any submerged object, to know whether it's stable or not, the center of the gravity, okay, relevant to the weight. Okay, any weight, kita kan ada pusat gravity kita kan. Setiap manusia ada pusat gravity kita. Lagi kalau lagi berat ke bawah, dia akan ke bawah lah, center of gravity. Okay, so if the center of gravity below the center of buoyancy, okay, in this picture, okay, so the object will stable. Dia tak akan berpusing-pusing, dia tak akan bergerak-gerak lah. Okay, that's one. On the second one, if the center of gravity is the same, same with the center of buoyancy, so that means it's still stable, but naturally stable. They're naturally stable. And the last one, if the G is above the B, the CG, the center of gravity, remember, is above the center of buoyancy, okay, CB, the object will be unstable. They will have a rotation lah, sama ada ke kanan atau ke kiri. Dia tak akan stable until it stop at rest. So that's the theory for any submerged body, stability or any submerged body. So it's very easy. You just need to remember CG and CB. The CG must be above the CB. Okay, so that's very simple. For the next scenario, the second scenario, which is floating body. Okay, this so the object is not submerged, it's floating. Okay, this level of water. So there are another component similar like submerged. We have the CG, center of gravity, and we have a center of buoyancy, CB. But in this case, we have another term. We call it metacenter, which is MC. Okay. So to know that the object is stable in a floating scenario, the center of gravity, okay, must be below the metacenter. Okay, G below the metacenter in this case, and above its center of buoyancy. Sama tadi lah. Okay. Bukan sama. Tak sama. Tak sama. Ni kalau yang submerged, the G must be below B. Okay. In this case, the G must below the metacenter and above the B, the CB. Okay. Jadi G tu mesti above buoyancy, but must be below metacenter. Macam ni lah. The center of gravity must be between this, above buoyancy but below metacenter. So why is that? Okay, let's see in this picture. Okay, this is stable lah. Okay, for this case, ini stable. Because the ship doesn't have any external force that push the ship horizontally. Okay, whenever the wind come to the ship or wave, okay, it will move it will rotate the ship on the horizontal line. Let's see this one. Okay, so whenever it move, you see the displacement will shape yang submerged tu, it will change, kan? It will change, because this level here have been sink a little bit down, so dia makin ke dalam, yang belah sini dia makin ke atas. Okay, kalau compare ni kan, ni makin ke atas, lagi besar sini, lagi kecil sini. So the shape below submerged is different. Okay, whenever it's changed, the center of buoyancy will move, will shift to a new position, and we call this B prime lah, B prime. So the new center of buoyancy. Okay, and the G will remain the same. Dia akan sama je. Okay, and this metacenter is the intersection between the center of gravity and the center of the new buoyancy. So this intersection, we call it metacenter. Okay, so when it have been put external force, there will be a restoring moment. We know the moment, dia akan balas balik, so that the ship will return back to its original position, like this. Okay, dia akan balik semula ke sini lah. So that means it's stable. But if you put more external force, if the wind is too strong or the wave is too strong, and it push the ship a little bit more, and then it will jadi shape macam ni. Okay, you will see belah sini makin dalam, belah sini makin terangkat di atas. Okay, so the shape beneath the fluid changes, and it will change the center of buoyancy. Okay, in this case, the buoyancy will be nearer to the line of the center of gravity. Okay, and whenever this happen, so now the B is nearer to the line of the gravity. So this intersection, the B and the G intersection, the M here is below. So your metacenter now is below the G, and this is not the same condition where it will stable. So this now the M is below the G, so it will give us an unstable condition. Okay, and because of this we have a moment, ada lagi moment, ada moment kat sini yang akan rotate lagi the ship ni, so it will capsize. The ship will have akan berpusing lah lagi kan, dia akan overturn the ship and akan tenggelam sampailah dia stop. Okay, so that's why the ship is unstable and this ship is not safe lah. Okay, because of the wind, the strong wind. Okay, that's the difference between the two scenarios, a floating body and the submerged body. The difference is in floating you have the meta center here, the meta center that will introduced by the intersection of the center of gravity and the center of buoyancy. Okay, so that's the theory lah. Okay, so ni again sama lah. So how we can in this question they will ask you to find where is the CB and where is the CG and where is your MC, so that you can know whether the object is stable or unstable. Okay, if your meta center is similar to your center of gravity, that means your object is neutrally stable. So ni still in the floating body. Submerged tu dah selesai dah. Submerged kita not to worry because it's very simple. It's just a CG and CB. But in floating we have this meta center. So if your meta center is equivalent to your CG, that means your object is neutrally stable. And if your meta center is higher than your CG, okay, the object will in stable condition. Okay, but if your meta center is lower than your CG, your object will be unstable and will have overturning moment. So this is the original condition, original position. Okay, you have so how you find I will show you how we can find the position of the CB and position of CG, everything. Okay, right. Oh, there's new people coming still. Let me okay. Okay. Ini just contoh lah for stability, immerse and floating. So this if someone you not really clear what is the difference between stable and neutrally stable. So this diagram show you clearly lah how what is the difference between stable and neutrally stable. If you see in this diagram, if you push this ball to another position lah, then it will go back to this position kan. So stable. Neutrally stable is still stable, but if you push the ball any way, it will move and then stop here kan. So it will not return to the original position anymore, but the ball still stable lah kan. And unstable lah, dia akan jatuh kan, kiri ke kanan lah. Okay, so this just for our understanding. Ini sebenarnya sama saya dah terangkan ni. So this is for immersed submerged body. So we just interested with the center of gravity and the center of buoyancy. So this whenever the center of gravity is below the center of buoyancy, the object is stable. Might be in this case for A, the weight is more at the bottom, that's why the G is lower. Okay, and the G is below the FB. But if you see for diagram C, maybe this ball the weight is more on the top. Okay, that's why the CG is higher. and is higher than the center of buoyancy, that means this ball will remain, it will keep turning whether on the right, on the left. Okay, so this is on submerge. So it's really simple, straightforward. Okay, now we want to see how we can answer any question regarding stability of floating bodies. So these are floating bodies. Okay, maybe a ship or whatever, I'm not sure. Okay, you have, like I said before, we have the CG, center of gravity, and we will have the CB, center of buoyancy, and we will have a meta center, MC. Okay, MC is the intersection between the CG and the CB. Intersection tu ialah meta center. So we need to find that. Okay, so this is the diagram. Okay, here they give you how you can what is the procedure to find the stability of floating bodies. First, you need to determine the position of the floating body using the principle of buoyancy. So this is the position of this floating body. So we locate lah the FB the like usual, the FBD. Okay, simple. Okay, now second one, you need to locate the center of buoyancy, CB, and then compute the distance from some reference as this. Okay, normally we take this lah from the bottom, from the bottom of the object. Okay, goes to your CB here, then we call it YCB lah. Okay, YCB. Okay, usually the bottom of the object is taken as reference. Okay, usually you take this bottom as this, bottom of the object. So first you locate your center of buoyancy, CB, and that's distance is YCB, this one. Okay, next you locate the center of CG pula. Okay, CG, and then the same reference level, the same reference from the bottom. So from here to your CG, you call it YCG. Okay, don't worry, how I will show you how you can find this distance, CB or CG. Now just learn what is the definition, what's the theory of this CB and CG. Okay, this the YCB. Remember, YCB is distance from the reference, so from the bottom to your CB, and YCG from the bottom of your object to your center of gravity. So you have your YCG. Okay. Next, number 4, determine the shape of the area at the fluid surface. Area ni, area of this fluid surface, and compute the smallest moment of inertia. So we know apa in the second moment of inertia. So this is on vertical plane because you rotate through this ni kan. Okay, so it depends on the geometry. Okay, whether you have a rectangular or triangle or circle, you will have a different formula lah. Okay, for rectangular, I think is the length times base cube over 12 kot. I'm not sure. I think we check. I think there is slide about this. Okay, I put it here. Okay, we will go here after this. We see. Okay, for rectangle, it's length times base cube over 12. The triangle, length times base cube over 36, and for circle, it's pi power 4 over 4. So these are 3 common shape lah. Okay, so you need to determine the shape so that you can calculate the second moment of inertia, IYY. Why? Because we will use this number in the formula to find your BM. Okay, then the next step is compute the displaced volume VD. Okay, so now you need to find the volume, the displacement volume lah yang kat sini yang tenggelam. Okay, how you can find it? Normally we calculate it using the area of the surface. The area of surface times the height the height of the displacement. So any apa, kalau lah kita katakan ni rectangle okay, the volume here okay is equivalent to the surface area of this rectangular dia macam ni kan, dia adalah satu apa rectangular ni okay, the surface area of this rectangle times this displacement height kan, HD okay, so we just want to find the displaced volume, not the object, the volume of the object, we just want to find the displaced volume. Okay, so you have find your displaced volume, and then the next one we can find the BM. BM, what is BM? Is the distance between from your center of buoyancy here, center of buoyancy CB ni, sampailah to your meta center so this is BM, and how you find BM is through this formula lah, second moment of inertia divide by the displaced volume. That's why you need to find need to calculate this second moment of inertia first, and then the displaced volume, so that you can find your BM. Okay, because the last thing you need to do is you want to find the YMC. YMC, the distance from the reference point, from the beneath, from the bottom until your meta center. Your meta center here kan. Okay, so this distance YMC is equal to, if you look the diagram, YCB plus BM kan. Betul. Okay, YCB plus BM. So you got your YMC. Okay, so that's why you need to find BM through this formula. And YCB is very easy. I will show you how you can find the YCB. It's just half of the displacement height. Okay, so that ini step dia lah. So whenever you find the YMC, if YMC is larger than your YCG, ni YCG the distance from your reference to your center of gravity. So if YMC larger than YCG, the body is stable. If not, if the YMC is lower than your YCG, then the body is unstable. So normally the question will ask you whether the shape is stable or not. And how you can find it? You need to find the number of your YMC, and then you compare with the YCG, whether it's larger or lower. That will tell you whether the shape is stable or unstable. Okay, so that's the theory. Maybe you not really get it, understand, but when you do the example, you will see clearly lah how this formula will be using to find the YMC. Okay, alright. So this procedure, remember, you need to find your CB, your CG, your MC, and then your BM. Find your second moment of inertia, and then find your volume of displacement, and then you can find your YMC. Okay, and you got it. Then you can tell us whether the shape is stable or unstable. It's very easy. It's not too complicated. It's just ada banyak step je. If you follow through step by step, insyaAllah you can find the answer lah. Okay. So ni dah cakap tadi. Maksudnya kalau the condition for stability of bodies in a fluid can be summarized as below. So completely submerged bodies, yang submerged tu dalam air, are stable if the center of gravity, your CG, is below the center of your CB. So yang submerged ni senang je, ingat ni je. Okay, for submerged. But floating ni yang senang juga, cuma you need to find your meta center. So if the center of gravity CG is below your meta center, maksudnya meta center lagi atas lah dari CG, then your object is stable. Okay. Okay. Okay, this I want to show you how you can find, because like I said previously, in floating bodies you need to find your CB, your CG and mental center kan. Tiga benda nak kena cari kan. From the question, normally you can straight away find your CB and find your CG. Okay, how? Okay, dia ini let's say we put ini yang dia floating kan. So this is a level of water. Okay, so di dalam ni air lah. Ini yang ke atas. Okay, so center of buoyancy. Okay, center of buoyancy here. Ni, you can find it by the height of displacement yang tenggelam ni, bahagian yang tenggelam je. Okay, divide by 2. Okay, and you find your center of buoyancy. Okay, it's easy like that. And for your center of gravity, it is the half of the total object, the height of this object. Ni yang displaced. Yang untuk center of gravity, the height of total object. Divide by 2, it will give you the center of gravity. Okay, senang kan? Senang tak?
Okay, good.
So
Senang saya.
Senang that's my side is very helpful lah when you want to answer a question. Whenever you see, oh ni senang, you can answer that. So your CG, remember, it is half of your total object. Okay, that's your center of gravity lah. Okay, when kita macam kita lah, kita manusia ni ada center of gravity dia, ada pusat gravity kita kan. And for YCB, center of buoyancy, where your force, the buoyancy force is acting. Ini awak cari daripada topik buoyancy kan. But we never know where the center of buoyancy. So center of buoyancy is the half of the height of the displacement yang tenggelam ni. Okay, tenggelam ni bagi 2 akan dapatlah center of buoyancy. So that's how you can find your CB and your CG. But with condition that there is no weight, there is no weight, additional weight. Maksudnya kat kapal tu je, bukannya ada lagi objek lain atas dia. Okay, so this one is the boat, is a cube kan. It's a cube. So if the question said, oh there is a weight on top of the cube, dia ada additional weight lain, so that you cannot using this lah. Okay, you cannot use only half displacement by 2 or only total height or object by 2. You cannot use that. Okay, so this is only without no external weight on top, and the shape is uniform. The shape here, what does it mean uniform? That means the shape on top is the same with the shape below the fluid. Maksudnya still atas ni rectangle, bawah ni pun rectangle juga. Bukannya atas ni rectangle tapi bawah ni macam bulat. Tak. In our lesson, in our chapter ni, we just deal with the uniform shape lah. The cube, not different shape. Okay. So that's how you find your CB and your CG. So the mental center is the intersection of CG and CB. That's will give you your mental center. Okay. So this tadi dia cakap to find your YCG, the total height of the object divided by 2. YCB, the total displacement height when yang mana tenggelam tu je, divided by 2. And your YMC, the distance from the bottom of the object to the mental center, is equal to the BM from your center of buoyancy to mental center. That's your BM. This let's say this is CB. Okay, and plus YCB from this is the level, the reference level, the bottom of your object, to your center of buoyancy is YCB, So this BM plus YCB will give you the YMC, the length from bottom to your meter center. Center. Okay. And how you can find your BM is just using this formula lah. Okay, the second moment of inertia IYY divide by the volume of displacement, the displacement volume. Okay. Okay, and this, like I said to you, any different geometry and the shape will have different formula lah to find the second moment of inertia. For rectangle, you will have the length times base cube divided by 12. For triangle, the length base times base cube divided by 36. And circle is pi r power of 4 divided by 4. And then they give you here the displacement volume. Okay, remember displacement volume. If the body is floating like this, so this volume that we want, we interested. So the area of this surface, rectangle, times this displacement height, HD. So that will give you the volume displacement volume. Okay, when you calculate this YMC, if it's larger than YCG, okay, remember YCG is this one, the total height of the object divided by 2. If your meter center, your YMC is larger, then it's stable. If lower, then it's unstable. If it's equal, then it's naturally stable. So that's only the theory. It's very easy, I can say it. So we can see some of the examples so that we can know how to do it. Okay, let's see example 1. So this is without external load. Because on this cylinder there is no additional weight that is put on this cylinder. Okay, we read the question. A solid cylindrical rubber spar buoy is floating in sea water as shown in the figure. Okay, it's floating, remember. So now we deal with the stability of a floating body, not submerged. The specific gravity Sg of the rubber spar buoy and sea water are 0.95 and 1.03. So sea water 1.03. For the rubber is 0.95. Okay. The diameter of the spar buoy is this diameter 0.5 meter. Okay. Determine the depth of this displacement height. The depth D of the spar buoy immersed in sea water. So that means they will ask you to find the H apa? Anyone? HO or HD?
HD.
HD kan? Okay. Dalam gambar ajar ni HO dia berapa?
5 meter.
5 meter. Okay, good. So it's very easy for the first question. Okay, we know that the FB equals to WN. Kita dah buat dalam topik buoyancy kan. There's a W down, you have your buoyant force upwards kan. Betul? Tadi Aiman dah buat tadi kan, for floating bodies kan. And then that's why you have FB equal to W, and you find your rho of the fluid G times V, the V displacement lah dalam ni, okay, equals to rho of the object times G times V of the object. Betul? Ni yang buoyancy yang terbaca kan. Okay. Now to make it simpler, okay, we know that VD is equal to the area times the HD kan. Ini tunjuk dia kan, this VD kan. the A surface, the area of the surface, times the displacement height. Okay, that's what you are going to find. You did not HD kan. Okay, and the V object, you can say the area of the surface times the height of the object lah kan, the HO kan. Okay, sama lah kan. Kalau cari volume of cylinder is the area of the circle times this length kan. So pi r square d kan, kalau ni d lah kan. So we have this area pi r square times d. Sama lah juga untuk this volume object, the area still the area times the HO, the total length. Okay, now we put this into our equation. Okay, so that give us the rho of the fluid times G times A HD is equal to the rho of the object times G times A times H of the object. Okay, now because we can make it more simpler by just cancelling out all the same term. The G we can cancel out G, the A also we can cancel out, it's just the same. So that then it left us with rho of the fluid times H of the displacement that you want to find is equal to rho of the object times the H of the object. Okay, so rearrange this, they give you the HD equal to rho of the object times the H of the object divided by rho of the fluid. What's the rho of the object here in this case? Anyone? Rho of the object.
0.95.
Apa?
950.
950 kan?
Yeah.
Because the SG times 1000 Okay. The height of the object?
5 meter.
5. The rho of the fluid?
The rho of the fluid
1030.
1030. And then it gives you the displacement height lah, and the HD that you want to find. What is the number? Berapa? $950 times 5?
4.61.
4.61 meter. Don't forget your unit. So this answer your first question. Okay, the depth D of the spar buoy immersed in seawater. Okay. Second question, they ask you to find the stability of this spar buoy from the metacentric height. Okay. So in this case, okay, they ask you about the stability of this floating body. So remember, you need to find your CG, your YCG, and your YCB. Okay. Your and then your Y metacenter lah. Okay, YMC. To find your YMC, you need to find BM, and you need to find your YCB lah. So this formula kan, ni formula yang akan digunakan. Allah, semua nak install dia. Alamak, tak apalah, saya dah record kan, nanti awal refer balik lah. Now we do the second question, the stability. So they ask you to the stability of floating. So you need to find your your YCG, your YCB, and your YMCN. Okay. how to find YCG again? Berapa? YCG.
HO over 2.
Okay, it's very easy kan? So HO is equal to 5
5 over 2.
over 2. That means it's 2.5
2.5.
meter. So that's settled for YCG. YCB?
HD over 2.
HD over 2. HD tadi berapa dah kira? Dah hilang lah. Saya dah tekan erase. HD berapa ni? 4.61. Okay, 4.61 divided by 2 with your YCB equal to apa? 2.3 2.3 je kan? 2.3 something.
2.3.
Okay, 2.3 meter Okay, you have your YCG, you have your YCB. Kalau you gonna use it, kalau YMC, remember, is equal to BM plus YCB kan? Correct? Okay, you have this. Okay, you have your YCG. Now you need to find BM. Okay, so BM ni again, BM equal to IYY over the displacement volume. Okay, so IYY for this shape, for is a apa circle lah, cylinder kan. So we have apa this area is pi r square, and we have the distance lah, whether apa the displacement distance, displacement height HD, and this is the height of object. Okay, so the VD, tapi tadi dah cakap kan, VD dengan A times the HD kan. Okay, so your VD is equal to pi r square times D apa? HD apa? Berapa HD?
4.61.
Jangan ni 4.61 ni. This will give you the volume of this displacement kat sini, volume yang dalam ni sampai sini je. Okay, sampai sini. Okay, what's the number? Pi r square. You have your arc, you have your radius, because it is half of the diameter. This is 0.5 diameter kan. Okay, pi times 0.25 squared times 4.61, and they give you berapa?
0.91.
0.91. Okay, 0.91. What's the unit?
Meter cube.
The cube. That's your VD. You need to find your IYY for circular ni, for circle is this pi r to the power 4 minus 4. Okay, we have pi r 4 over 4. Berapa IYY?
Zero point zero five.
0.04.
05.
Betul pi r power of 4, r ni 0.25 kan?
Okay guys, salah. Ya.
Minus divide by 4. I think it's more smaller.
3.
Smaller. Okay,
3.07.
7. Itu je, meter ke apa?
Itu je.
Ya ke awak ni?
3.07 times 10 power of negative 3.
Times 10 of power negative 3 kan?
Yes.
The unit? What's the unit? Unit dia apa? R04.
Meter
Meter
R04.
power of 4.
Meter 04 lah. Okay. Don't forget to put unit so that you not confuse the end apa the last value tu apa unit dia because you want to find your BM kan. So YIYY is 3.07 times power of minus 3 meter power 4. So divide by the volume 0.91 meter of 3 the power of 3, so that gives you in meter lah because you want to find your BM kan. So what's the value for BM then? Berapa meter jadi? Ni divide by ni. Berapa? Apa value dia?
3.371. 3.371.
3.371
Darab 10 negatif 3.
darab 10 negatif 3
meter
Meter.
Yes.
Meter.
Okay, so that's your BM So you have your BM and you have your YCB. Now you can find your YMC lah kan. So YMC equal to BM plus YCB. Berapa jadi jumlah dia? The YMC BM plus YCB. YCB is here 2.3 plus 3.371 times 10 power of minus 3, so you give you 2.3 something
2.30
2.303.
yes
Okay, meter. Okay, now you have your YMC. To know whether it's stable or not, you need to compare with dengan apa?
Compare with YCG.
YCG kan? Okay, now your YMC is 2.303. Your YCG is
2.5
2.5. Okay, tell me whether it's stable or not.
unstable
Unstable.
So it's lower kan?
yes
Yep.
So your answer will be unstable. So you have already find your YMC 2.303, which is lower than YCG 2.5. So this is unstable. Senang kan?
Boleh lah sir.
boleh lah
Saya cakap dah senang. Cakap boleh agak. Tawaduk. So it's very easy. It's very easy. Just whenever you have a floating body, you need to find all the YCG, YCB, and the meta center and your BM. So just follow the step with the one that we did before. This step, okay. Locate your YCB, YCG, and find your volume, displaced volume, and then find your BM. So that's one example without external load. So we see with external load now. Okay. Now it's different lah. Okay. Cakap dia kalau ada load, you cannot just find your YCG kan, just divide by the total object with 2. You cannot do that. Okay. Your CG will not be HO over 2. Okay. You need to find it. Okay, now we see the question. A sand boat is used to transfer sand from a quarry to a factory along the river stream. Tadi sebab apa? 12 kan? The mass of the sand, okay, they give you the external load. The mass of the sand loaded into the boat is 50 ton. Okay, remember they give you in ton. Determine the stability condition of the sand boat. Okay, find it whether it's stable or unstable by calculating the YMC. Okay, the difference between the example 1 is we have an external load on the boat. Okay, that's only the difference. Okay, what is the mass of the sand? 50 ton. We need to convert in kilogram, right? Because we use a standard unit. So what's in the unit of kilogram?
50,000.
50,000, so 1 ton equal to 1,000 kg. So now the mass of this sand is equal to 50,000. So don't forget to convert it in the standard unit. Okay, now you have your ton. Okay, in this question they already give you your YCG. This is YCG. This is a point of the center of gravity is 1.5 meter. Okay, this 1.5 meter. So YCG is equal to 1.5. Okay, so you cannot just divide this 2.4 by 2. We not give you YCG. They already give you the YCG. Okay, is equal to 1.5. Okay, that's one. And then for this you have your mass. So you can find your W lah kan, which is mg. The weight of this boat with the with the weight of this external load ni, you have your mass 50,000 times G. We give you the weight, which is, what's the value? $50,000 times 9.81. Berapa?
490.
49,500.
490,500.
Okay, 490, 500. What's the unit? W, unit dia apa? Apa unit dia?
Newton.
Newton. Don't forget the unit whenever you do calculation, put the unit so that you sure that the value is correct. So now you have your W, which is your FB lah, because W kat sini ke bawah. Now you have your buoyant force kat atas, so that the FB equals to W. So this W is 490,500, and your buoyant force, you know, is rho of the fluid. What fluid is this? Water. Okay, water. G. Okay. Area times HD. Ni D kan? Okay. HD sini. We are interested in this volume. Okay. So AHD ni volume of displacement lah. Okay. So now you want to find your HD kan? Before anything, before we calculate the stability or not, whether it's stable or not, so you need all the property lah. Okay, your HD will be 490,500 divided by, you put everything here, so rho of the water G times A. Find your HD kan? To find this displacement height. They did not give you kan? Tak ada bagi sini kan? Dia bagi only center of gravity. Okay, you need your displacement height. Why you need your displacement height? Sebab apa dia cari benda ni? Anyone? Remember the formula?
To find YCB.
Huh? Kan? Kita nak akan jadi YCB nanti kan? And this YCB is the half of your displacement height. That's why we need to find this displacement height. Kan? Okay, your displacement height here. Okay, so 490,500 divide by the row of water 1000. So this is 490,500 bahagi 1000 times G. So what is the area of the surface? Area of the surface. Apa area? Berapa? Anyone?
So jarak 10.
Berapa?
2 times
2 times 10 kan? Kalau dia give you this length, side view kan, belah sini. Apa mata ke belah sini kan? This is 10 and this is 2. Okay, so your area of surface 20 lah, 2 times 10. Okay, and this give you the height of this ni lah, displacement height berapa jadi HD? Ada kan? Berapa? Ni bahagi ni
2.5.
2.5. Okay, 2.5. What's the unit? Meter
Meter.
Okay, so now you have your HD 2.5 meter. Okay, that's one step. So you know your HD. Okay, now you can solve this problem. Okay, you have your YCG is 1.5. Okay, just write it here. YCG is given to you 1.5. Okay, here this height. Okay, and you have your YCB. Okay, so you already calculated the HD. HD divided by 2, which is 2.5 divided by 2 berapa? 1.2 5 kan? Okay, this is your YCB. So you have your this is CG, you have YCB somewhere below here. Okay, this is 1.25. Okay, and okay, you know the formula that you want to find YMC sama dengan berapa? YMC, what's the formula?
YMC equal to MB
BM. Okay lah, MB boleh lah, BM lah, BM. Standardized. Plus
YCB.
YCB. Okay, you already have your YCB. What you need to do is to find BM kan? Okay, BM, apa formula BM?
IYY
IYY
divide V.
of dividend, the displacement volume Okay, how to find IYY for this shape rectangle?
LB cube over
LB cube over 12. Okay, good. So your length is 10 times base 2 cube over 12. Okay, what's the number? 10 darab 8 bagi 12. 80 bagi 12 berapa? 7, 6. Berapa?
6.67.
6.67. Apa unit dia? Remember? Meter
Power of
3 lah. Kan? 4 LB kan? 4 kan? Kan? Okay, so that's what your IYY. Your V, displacement volume, remember, is equal to apa? A times
HD.
HD. Okay, so your A is
20.
20. Your HD is
2.5.
2.5.
2.5. Okay, then give you 50 again. Alright, so you have your IRY, this 50 meter cube, don't forget. So meter cube. So now you have your IYY and you have your V. Now you can find your BM lah. BM is equal to 6.67 over 50. Berapa jadi?
0.1334.
0.1334 apa?
Meter.
Meter. Okay, don't forget your unit. Okay, then you can find your YMC lah. So you have your OD or BM. So YMC equal to 0.1334 plus your YCB is mana?
1.25.
1.25, sorry. 1.25. So this is equal to berapa jadi?
1.38
1.38 meter.
meter.
Now you can compare your YMC with your YCG. Your YMC is 1.38, or your YCG is 1.5. Again, it is lower kan kan? Betul tak? Is
Yes,
lower.
lower than
yeah.
So that means it is
Unstable.
unstable. Senang.
senang ke?
Senang kan? So apa? Mudah, mudah. Just need to aware of this equation to find all this property that you need to use to find your YMC kan. Okay, itu je lah, itu dua example lah. Satu untuk external load and one without external load. Okay. Any other lagi? Oh, satu lagi. Okay, we have one more. Okay, I have shown the step to you, so I need one of you to show me how to do this. Okay, figure shows a flat boat hull that, when fully loaded, weighs 150 kilonewton. Note the location of the center of gravity. Dia bagi dah sini, the CG 0.8 to determine whether the boat is stable in fresh water. Okay, in tadi salah. Sorry. Okay. So tell me whether this is with external load or without the external load.
With.
With, okay, because they have weight of 150 kilonewton. So they give you in kilonewton. Okay, so that's give you already the W is 150,000 Newton. Alright. Okay, siapa nak buat ni? Sama juga macam ni, sama je macam before. How we do this? Siapa? Olen lah, bukan Iman lah, Olen. Amirul Sorry, saya petik nama pula. Siapa nak buat? Tak ada orang nak buat ke? Ha? Kalau dapat buat ni, dapat skor lah. Test, quiz. Siapa ni? Ada yang cakap Hello? Macam mana kita? Just the same step with this. Sama je. So they gave you the CG already?
Saya cuba.
Boleh, tak ada hal. Jangan takut. Alright.
So kena cari, mula-mula cari HD
Yes, correct. So let me draw so that people can. Ni gambar kat sini gambar yang ni dia baris tu. So jadi level water. Sekejap saya tukar dulu. They give you the CG. This is 0.8. Okay. Then we know the W. Okay, apa sama nama lupa dah.
Daniel.
Oh Daniel, okay Daniel. So first find your HD yang ni.
So HD equal to weight.
HD equal to weight.
Weight over raw water.
Okay.
Times gravity times area.
Times area. Area? Oh kau dah terus jam ke sini
Oh nak ni nak
okay.
Dia punya tu dulu
takut ada yang tak terfollow. Awak dia terlalu advance lah.
Okay. Start daripada tu dia punya equation.
Equation betul. Saya saya padam. Macam nak padam sekejap Sekejap. Eraser. Saya padam mana? Okay. Sekejap Okay. Okay again. Apa equation dia apa?
FB minus W equal to 0.
Okay. Ada
FB FB equal to W.
Okay.
Okay, so FB dia apa tu? Raw water times gravity
G
times area times HD
okay,
equal
correct.
to 150,000 Newton.
Okay, but they give you here kan. Okay.
Then rearrange.
Okay.
HD equal to 150,000 over raw water.
Raw water berapa? 1000.
Raw water 1000
Times G
times area.
Area berapa? Berapa area dalam question ni?
6 meter.
Okay, 6
times 2.4.
times 2.4. Okay, good. So this will give you berapa? 1000. Ni bahan kalender ni
141,000.
141,000.
264. 141 141,264.
Oh, 264.
Yep.
Betul Oh, kira ni bagi ni.
Oh, ya.
Macam panjang sangat ya.
Jap.
Okay.
1.06.
1.06. That ni logik sikit.
Tak bagi.
Tak bagi. Okay. Okay, 1.06 meter This is your HD sini lah. Okay, 1.60 meter. Okay, next what we do?
We find YCB.
Okay, YCB sama dengan
HD over 2.
bila betul, which is
0.6 minus over 2, 0.53.
53. Okay, your YCG YCG
YCG
ni dah bagi dah
0.8
kan?
meter.
Ni. Okay, 0.8. Okay, good. Okay, what's next?
Next we find YMC.
Okay, YMC. What's the formula for YMC?
YMC equal to BM plus YCB.
Plus YCB. Okay, good. So how you find BM?
BM equal to IYY over displacement volume.
Okay, good. And IYY equal to?
IYY equal to LB cube over 12.
Cube over 12. And your volume of displacement?
Hmm. 2.4 6 over 12 6.12.
Ni apa? IYY
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 6.912
meter per 4
meter.
Okay, your VD sama dengan apa? VD?
VD
Apa formula dia? Remember?
Area times with HD.
Yes, area of the surface times HD. So this area is
Area 2.4 times 6
okay, times 6 times HD.
times HD. HD is 0.53.
0.53.
53.
No,
Equal.
HD, not YCB.
Oh, HD. HD 1.06.
Don't apa? Careless. 1.0 kan?
6.
Okay, so what's the value for BM then after you divide by these two? 9.6, 7.912 divided by this.
BM is 0.45
0.45 meter kan? Okay. Next, what you do?
So we go to the YMC.
Okay, ni sini. So
Okay, put the value of BM and YCB.
45 plus YCB berapa?
YCB 0.53.
So this is equal to
0.98.
98. Okay. Now what you do?
Now we compare with the YCG.
Okay. So your YMC is 0.98. Your YCG is
YCG is 0.8.
0.8. Okay, tell me then what's the conclusion?
The conclusion is YMC is bigger than YCG, so
Okay.
the body is stable.
Stable. Yes, correct. Okay, senang. Apa siapa nama lupa dah dia? Amirul eh?
Daniel.
Daniel sorry Daniel. Senang?
Senang sir, senang.
Senang Yang lain senang kan? Yang lain? Dah itu je lah. As simple as ABC. Any question?
No sir.
Yang lain-lain?
No, sir.
Tak ada eh? Tak ada? Okay, bagus. Thank you. So I think that's all for topic stability. That's why I recap first before, because it's related to buoyancy, because you still need to find your FB. But before this, for buoyancy, you never locate where is your center of buoyancy, kan? But in stability, you need to locate that. Where is your center of buoyancy, and where is your center of gravity, and then you need to find your metacenter, and then you can find whether the shape is stable or unstable using by comparing the value of YMC with the YCG, the center of gravity. So that will tell you whether the fluid is stable or not stable. Okay, like I said, there are two scenarios. Okay, whether the object is submerged or the object is floating. And submerged is very easy. There's not much calculation. It's just locating where is your CG and your CB. But in floating, there is calculation. You need to calculate where the distance of your YMC, so that you can know whether it is stable or unstable. Okay, so much more information or more problem is normally related to the floating body lah, the one that is floating. Okay, I think that's all. If you don't have any more question, okay, let me stop the recording first.